Collision and intersection. In this presentation, I will just discuss the problem involving the car and van. This one, yeah, this problem. Start by first identifying the given. This system involves two particles, the car and the van. For this, we'll use C and V. You can also use one or two. Kayo bahala. Before the collision, we have for the car, its mass and velocity. So this is car initial. And for the van also, we have mass and velocity. This is van initial. After the collision, since this is a perfectly inelastic collision, the car and van is taken as one particle after the collision. Hence, their mass, the final mass, is a combination of their masses. It's 1.5 times 10 to the third and 2.5 times 10 to the third, giving us 4.0 times 10 to the third. I just used F for final mass, but it's okay if you want to use C, V, F, or C plus VF, or 1 plus 2F. Bahala kayo. Now, we are looking for the final velocity. For our solution, remember that based on the law of conservation of momentum, initial momentum must be equal to the final momentum. Now, here in this particular problem, because this is a collision on an intersection, we will not be getting the summation of their initial and final momentum. Diba in our other problems, what we do is we add all the momenta of all the particles in the system, initial and final. Here, we cannot do that because their collision happened at an intersection. Hence, their final velocity is at an angle. Okay, so we need to take them separately, separate particles. So let's start with the car. The car is due east. Same formula. Mass times velocity initial must be equal to mass times velocity final. But here we have a cosine theta factor since it happened nga at an intersection. Why cosine? Because the car is due east. So x-axis. We will use cosine if the direction is east or west. Substituting mass of car initially, velocity of car initially, their final mass, unknown yung final velocity, and the angle. Multiplying 1.5 and 25, we'll get 3.75 times 10 to the fourth power. The right side of the equation stays the same. This is our equation 1. For the van, again, same principle, law of conservation of momentum. Initial equals final momentum. The van is due north. Formula, initial mass, initial velocity must be equal to final mass, final velocity, sine theta. So we used sine because it is at the y-axis. So we will use sine for particles moving north or south. Substituting the given initial mass of the van, initial velocity of the van, their combined final mass, the unknown. Multiplying 2.5 times 10 to the third power and 20 will give us 5.00 times 10 to the fourth power kilogram meter per second. The right hand of the equation stays the same. This is our equation number 2. Now, combining equation 2 and equation 1, so we have two unknowns We have VF and theta. So, two equations, two unknowns, madali lang yon. We can divide these two. If we divide equation 2 and equation 1, we will have this over this. Ito yon. And cancel lang tayo nito at nito. Ang natira, sine over cosine. The left hand side of the equation is just equal to 1.33. Use your calculators. And sine over cosine is just tangent. Baliktarin lang natin para nasa left yung unknown. Solving for theta, we use inverse tan or arctan, 1.33. You can just use your calculators for this and you will get theta equals 53.1 degrees. And now we have an angle. We can use either of these two equations to solve for final velocity. Again, I repeat, pwedeng sine, pwedeng cosine. Maalin man dito sa dalawang to, you will still get the same answer. For the purpose of this solution, I will use equation number 2. So what happened here is this, huwag niyo muna tingnan itong baba. Itong taas, itong buong taas lang yung equation 2. Diba? Ito, tsaka ito, same lang. Now, we need kasi to isolate VF because that's the unknown. So, therefore, we will divide lahat ng katabi niya para makancel. Divide both sides lang. Okay? So, matatanggal na to lahat ng katabi ni VF. Ang natira na lang, ito. Then, sinubstitute ko lang si theta with 53.1. Then, using your calculators, you can now solve for final velocity. That's 15.6 meters per second. For the final answer, after collision, the vehicles are traveling at a speed of 15.6 meters per second at 53.1 degrees north of east. And that's it.